one book where, no, you have to do everything on by yourself. The other, you can look in your notebook. What happens to our exams if we say they're now open internet? Here's the exam, use the internet. What kind of questions do we stop asking, and what kind of questions do we continue to ask? That's the question, because that's the future. We don't have to ask anymore, what is the height of the Eiffel Tower? We don't have to ask, what is the specific heat of aluminum? I can find those answers on the internet very quickly. So these are the questions I think we should be asking. What does it mean? How do we know? Why do we believe it's science? And why should I care? And that's what I wanted to talk about today. Now, we started a bit late. How much time do I have? So here are some questions in science that we think about. Here are some things we know in science. Newton's second law, F equals ma. Energy is conserved. The earth goes around the sun. The atom has a nucleus. Mitochondria are the powerhouse of the cell. H2O is a polar molecule. We even know the angle. Our textbooks and classrooms are full of this information. You can all answer these questions and tell me, what does it mean to say F equals ma? It says, oh, bigger force, bigger acceleration. What does it mean to say energy is conserved? Energy is neither created nor destroyed. We know what does it mean, but there's more to what does it mean. So in active chemistry, we say, what does it mean in chemistry? Well, in chemistry, we have the macro, the nano, and the symbolic. In chemistry, we look at phenomena that occur in the world. That's the macro. And then we say, chemistry people say, can I explain that at the molecular level, at the nanoscopic level, with molecules? Can I explain this? And then finally, to do that, they need symbols, they need structures. So here we have Boyle's law. In Boyle's law, the macro is, if you compress a gas, the pressure increases. It's hard to compress it more and more and more. So the macro is, how does the pressure affect the volume of gas? The nano is, draw a picture of what you think is happening to the molecules when you change the pressure. And the symbolic structure is a graph, which tries to show you from A to B what happens with the pressure and the volume. So what does it mean is more than just PV equals nRT, it's these kind of questions. So instead of simple recall questions, what is the chemical symbol for calcium? What is the acceleration due to gravity? Which gas is required for photosynthesis? We have questions of what are the products when these two chemicals react? How far will a ball fall? Why is light required? Now, I once had a conversation with a principal of the primary schools, 3rd grade, 5th grade, 6, 7, 8, 9-year-old boys and girls. And the principal said, oh, the children must know the order of the planets. Mercury, Venus, Earth, Mars, Jupiter. I said, really? They have to know that? They said, oh yes, this is very important. They should know this. Mercury, Venus, Earth, Mars. I said, okay, but when you teach that, please don't do it during science time. He said, why not? I said, it's not science. It has nothing to do with science. It's what's left over after the science is done. After the science is done, we know it's Mercury, Venus, Earth. The science question is, what does it mean to say that Venus is closer to the sun? Because already it means, oh, the sun's at the center and the planets go around. And then, but the more, how do we know Venus is closer to the sun? Mercury, Venus, Earth, Mars. How do we know Venus is closer to the sun? Now, what is the evidence? Well, two things. One, we see Venus in the evening. The sun goes down and there's Venus. We never see the sun go here and Venus over there. Because if we saw that, it would be like sun, Earth, Venus. No, it's sun, Venus, Earth. Another way is 2 years ago, in June, we had the transit of Venus. In the middle of the day, Venus went in front of the sun. Sun, Venus, Earth. If the Earth is there, you can't have Venus go in front of the sun for us to see. So that's the science. And that brings us to this question, how do we know? So how do we know Newton's second law? How do we know energy is conserved? How do we know the Earth goes around the sun? So I would like to tell you, in America, everybody knows the Earth goes around the sun. No, 80% of people know the Earth goes around the sun. Only 49% know it takes 1 year. This is in America. It might be better in Kathmandu, I don't know. But then if I ask people on the street, does the Earth go around the sun? Yes. How long does it take? 1 year. How do you know? And they say, my teacher told me. Isn't that correct? Isn't that the right answer? 1 year, my teacher told me. And my teacher said if I say the Earth goes around the sun, I get a smiley face. If I say no, the sun goes around the Earth, I have to do it over. That's how I know. That's not how we know. But what is the evidence we have for the Earth? Well, we have careful